This bit of the high physics course takes us into some pretty recent discoveries just in the mid-20th century about what the universe is actually made of. So matter and gravity, what Newton described, aren't really the full story. We've got a couple of bits of evidence, one to do with the orbit of stars around a galaxy, and secondly to do with observations of redshift. To be fair, in the 13.7 billion years that you've just calculated the age of the universe as being, then not all of that matter has actually been what we call baryonic matter, neutrons and protons that are the baryons which make up everyday stuff that we experience. Some of it is dark energy and dark matter. We get this evidence from the idea that we are in a spiral galaxy, that the galaxy rotates and our sun is just there roughly in the galaxy. The galaxy that we are in is what we see the night sky, the Milky Way. If you look above on a dark night, then you'll see a real band of stars. You're looking through the cross section of our spiral galaxy. If we look at it from above, then you've got the rotation of the sun going around there, and that's pulled in towards the center of the galaxy by gravity, just in the way that the Earth orbits the sun. Because they've got different amounts of gravitational pull, then the different distances, they orbit at different speeds. And it's this that allows the astronomers to work out how much mass there is in a galaxy by the orbital speeds there. When we plot the speed of the galaxies against the distance from the center of the galaxy, what we would expect to see is this curve here. In reality, the speed of the stars is observed as being much higher. And that means that there's something missing. This has been confirmed by microwave radiation, and it's this dark matter which makes up the gap there. Okay, so it can't be observed because it doesn't interact with light, but there seems to be a significant amount of mass, much more than the baryonic mass, which is observed, not just predicted from Newton's laws of motion. So the SQA statement is that the measurements of the mass of the galaxy and others lead to the conclusion there is significant mass which can be detected, and that's dark matter. And you're going to be watching a video on this in a moment. The other thing is to do with how the universe expands. We know from redshift that the universe is expanding. So if that's the age of the universe in billions of years, that's where we are at the moment. That's the 13.7 billion years ago, and this is the future. Long term, what's going to happen to the size of the universe? This is the universe increasing in size with a linear increase shown by that blue line there. If gravity was to start to pull the universe back in, then the size of the universe would get smaller and smaller, and you would end up with a big crunch that the universe would kind of implode on itself in roughly 20 odd billion years time. So that's if gravity wins over the expansion. The observations that we've got at the moment are that the universe is actually increasing its rate of expansion. But it's not getting further away, but it's doing it more quickly. And that increasing expansion can only be explained by something which is providing that energy. And so the term that's used by astronomers is dark energy. And it's that which is causing this red line to increase the rate of expansion of the universe. So if this was plotted out as a simplified diagram, you've got the Big Bang, expansion of the universe there, and that actually starts to accelerate, so the universe is even bigger than it was, and not only bigger, but it's actually increasing. So be a short video as well to watch on that from BBC in a moment, but just to summarize, so we started off with this, that at the start of the universe there was a lot of dark matter and non-baryonic, but now we've actually got more dark energy and less dark matter in the universe. So both of which are much more prevalent than the atoms of neutrons and protons which we experience. Hence the theories of the future of the universe. So that's just summarizing what you should know.